Okay, fine. So as you guys know that we have started with quadrilaterals in the last to last class, and now we are at the exercise 8.2. Okay, now today we'll be continuing with the same. Also, we'll be doing with this midpoint theorem as requested last time. Okay, we'll be doing the midpoint theorem also. Let us do the midpoint theorem first. Just a moment, let me open the textbook. Now, first, what is midpoint theorem? You should be knowing. What does the theorem states? This is what your theorem. That is a line drawn through the midpoint of one side of a triangle parallel to the another side bisects the third side. Now, what does this mean? See, that is if you suppose if you have a triangle like this, okay, if you have a triangle like this, and suppose you have a midpoint of this side, okay, and if you are drawing a line which is parallel to the third side, okay, a line which is parallel to the third side, then what happens? What they have said, the line drawn through the midpoint of one side of the triangle, through the midpoint of one side of the triangle parallel to the another side bisects the third side. Bisects the third side, that means it bisects this side. That means this point is also the midpoint. That's what you need to prove also. Got it? This is what the theorem states. Means if you draw a line parallel to the third side, which is starting from the midpoint of one of the side, then it will bisect the third side. Okay? Now how to prove this? Okay, let us try to prove also. If I have this as my triangle, suppose this is your triangle. Okay, this is your triangle. Just consider. Now what all things they have given? Yeah. So what all things we know in the given? If this is A, B, and C, what all things we know in the given? That is, if this is A, B, C, D, and this is E, what do we know that is AD equals BD? Because D is the midpoint. This was the given data to us. Also, what do we know? That DE is parallel to BC. These are the two things which we know already, right? Now to prove this, we will have to do some construction. First, let's write what we have to prove. What is to prove in this? That is AE equals EC, that it bisects the third side, right? This is what we need to prove. Now to do the proof, we'll have to do some construction in it. Okay, the construction is draw CF parallel to AB. Draw CF parallel to AB. That means I will have to draw a line CF parallel to AB like this. Got it? I have drawn a parallel line over here, which is fine. I have draw CF parallel to AB, parallel to AB, so that DE extended DE extend meets at F. Got it? If DE is extended, it meets at F. Fine. Now we'll do the proof. Now in triangle ADE and triangle ADE and FCE, in these two triangles, we know that AD is parallel to CF. Why? Because by construction. We know this by construction that the two lines are parallel. Now, if these two lines are parallel, can I say this angle is equal to this angle?
Yes.
Yeah. Angle DAE is equal to angle ECF. Yeah. Alternate angles. Also, can I say AE is equals to EC? What will be the reason of this? Sorry, not AE is equals to EC. We do not know it. We do not know it. Wait.
Sir, we can do DF equals FD.
DF equals
FD. Common side.
DF equals FD. No, how you can say DF equals FD? No.
Sir, DE is equal to EF.
But how do you know it? We do not know it, no?
Sir, we can say
Sir,
AD equals
angle
Sir,
FC.
AED,
angle.
sir, angle AED equal to FEC,
Yeah, that
vertically
is fine.
opposite.
That is vertically opposite angles. Also, this angle will be equal to this angle. Means all the angles are equal. I can prove, but I have to prove that the two triangles are congruent. Right? For the congruency, I means only the two angles is means three angles are not sufficient. At least I need one side.
Sir, Sir, AD equals FC because they are parallel, and if it's midpoint of one parallel line, so it will be the midpoint of the other parallel line
That's what
as
we
well.
need to prove. AE is equals to EC. That's what we have to prove. We are doing the same
No,
theorem.
sir,
We
I
cannot.
am telling AB parallel to CF.
Yeah,
So
AB
we
is.
can say
Yeah.
AD parallel to AD equals FC.
No, no, we cannot say that. No, we cannot say that. Wait, just a moment. I'll tell you. Wait. I think I have drawn this line on a wrong side. Suppose, wait, we'll not draw this line over here. We'll not extend this line over here. We'll remove this F also. This also. Wait. Yeah. This is B, and this line is also drawn. Okay. Now, I will draw a line which is parallel to this AC. I'm drawing a line which is parallel to AC and I'm extending this. Okay. And just we'll say that this is what your F. Okay. So whatever we have written, draw CF. So instead of CF, I'll write draw BF. BF parallel to AC. Parallel to AC so that DE extends meets at F. That is fine. Okay. Now AD is equals to BD that we already knew, right? That's what we already knew. That thing we can take in given. So in triangle ADE and triangle ADE and F. Wait, now the triangle name also has to be changed. If it is triangle ADE, it should be BDF. Fine. AD is parallel to. Wait, this will also change. Over here, what do we know that BF is parallel to CA by construction. Okay, by construction. The same thing we are doing. Over here, instead of this, we'll be writing, yeah, we know that AD is equals to BD. This was given. Yeah, this was given. AD equals to BD. That this side is equals to this side. Also, this side angle, this angle will be equal to this angle. Yeah. So, angle FDB is equals to angle ADE. That's again what? Vertically opposite angles. Also, angle FBD is equals to angle DAE. Why? Alternate angles.
Alternate.
Yeah. Since the two triangles are, means since these two lines are parallel, no, that's why. Right? Now can I say that the two triangles are congruent by which test?
ASA.
ASA.
Yes. Therefore, triangle ADE is congruent to triangle FD. ADE is congruent to FDC by ASA test of congruency. Okay, ASA test of congruency. Now once the two triangles are congruent, right, can I say that is FD is equals to DE? Also I can say FB is equals to AE. Therefore FB is equals to AE. Yeah, we'll take the diagram over here again. Yeah, so FB is equals to AE by CPCT. Okay, also what FD is equals to DE. This is also by CPCT. Fine, this is what I got, right? Now what I have to prove, uh, this is done. Now in quadrilateral FECB, FECB, okay, in quadrilateral FECB, I know that FB is parallel to EC. Yeah, by construction. Yeah,
Yes.
I know that by construction. And FB is parallel to EC by construction. This is equal to, yeah, wait. This is equal to this. This is equal to this. This is equal to this, and this is equal to this. This, just a moment. FB is parallel to EC. This side is equal to this side. E is the midpoint or not? Oh, it was given. Wait. The 2 points are, wait, what is the theorem? The line drawn through the midpoint of one side. Okay, wait. This is one theorem. Wait. We have taken the statement only wrong. That's why we are facing a problem. This is not the statement. The statement is this. The line joining the midpoint of two sides of a triangle is parallel to the third side. Okay. So this is what the statement is. The line joining the midpoint of two sides. What I was taking was this. The line drawn through the midpoint of one side of a triangle is parallel to the another side, bisects the third side. This is actually the converse. That's why we were not getting the proof. Now the actual statement is this. For the midpoint theorem, the line segment joining the midpoint of two sides of a triangle is parallel to the third side. Now see to it. How we have to prove. If I draw a triangle like this, if I am drawing a triangle over here, yeah, suppose this is your triangle, and these are the two midpoints. We know it. Okay, we knew that the 2 points are the midpoints, right? If this is A, B, and C, this is E, and this is F. Okay. Now what is given in this? AE is equals to EF, EB. This is given, and the second thing which is given is AF is equals to FC. So both the things are given. Okay. The line segment joining the midpoint of two sides of a triangle is parallel to the third side. Now the only thing we need to prove is that this line EF is parallel to the third side, that is BC. Okay. Now how to prove that? For proving it, what I will do will let's write the proof. What we have to prove over here. To prove is what you have to prove, that is EF is parallel to BC. That's what we need to prove, right? Now to prove it, we will have to do some construction in this. Yeah. Now the construction is draw C A B C C D. Let's say draw CD parallel to AB. Okay, that is draw CD parallel to AB. So if I draw it, it will be like this. Okay, it should be parallel to AB, and then extend EF to meet at D. That is, I will extend this. Fine. This will meet at D. Is this clear? Yeah. Now, now let's write the proof. Now we will be able to prove it because see, in the last time it was we were not able to prove it because it was not given both the points are midpoints because we was taking the converse of that. That's why it was unable to prove. Okay, the main proof is this, means the statement should be taken as this. Okay, now see to it. How to prove it? In triangle AEF and triangle AEF and CDF. Okay, in triangle AEF and CDF, what all things we know? That is AF is equals to FC. That's given. Yes or no? This was given. After that, this angle will be equal to this angle, alternate angles. Angle EAF is equals to angle FCD, alternate angles. After that, this angle will be equal to this angle. Why? Vertically opposite angles. That is, angle AFE is equal to angle CFD, vertically opposite angles. Therefore, what I can say? Therefore, triangle AEF is congruent to triangle CDF by ASA test of congruency. Fine. The two triangles are congruent by ASA test of congruency. Now, once we know that the two triangles are congruent, then what we will do? See over here, the two triangles are congruent, no? So I will say that AE is equals to FD, sorry, DC. AE is equals to DC by CPCT. Also, I can say that EF is parallel to FD. EF is equals to FD. Why? Again by CPCT. But AE is equals to BE. This was given. Yeah. So therefore, can I say BE is equals to CD? Because these two are also equal, no? But this and this are equal by congruency. So this and this are also equal. Therefore, what I can say? BE is equals to CD. Got it? Yes or no? You can nod your face. Got it or not? Yeah? Okay.
Yes.
Fine. Now once if BE is equals to CD, now if I say in quadrilateral, if let's say this has 2. Now in quadrilateral BECD, what I know that is BE is parallel to CD by construction. I know this by construction, and BE is equal to CD, proved above. So if a line, if the opposite lines, if the opposite pair of a quadrilateral are equal and parallel, then the quadrilateral is what?
Parallelogram.
Yeah. Therefore, quadrilateral BECD is a parallelogram. Now, if it is a parallelogram, so can I say EF is parallel to BC?
Yes, sir.
Yeah.
Yes.
Therefore, EF is parallel to BC, and that's what you are hence proved. Got it? This is what your midpoint theorem is. Understood? Any doubt over here you can ask. The last time we were unable to prove it. The only reason was we have taken a wrong statement. That's why. Clear everyone over here?
Yes, sir.
That last part when you did that CPCT, that chemistry.
Yeah. Which one?
Yeah, A equal to BC.
AE equals BE. This one?
BC.
AE equals BC. Where I have written?
BC.
BE equals CD I have written.
The first one, AE equal to BC.
AE equals to DC. Yeah, by CPCT, no? These are the corresponding sides, this and this side. See, these two triangles are congruent, no?
So
Yeah.
that EF equal to FT, that why we need to write.
Which one? EF
EF
is equal.
equal to FT.
This was not required. This
Yeah.
was not required. Yeah, this was not required, but still I have written it. I thought we will be using it, that's why I've written, but it was of no use. Clear? Any doubt over here?
Yes.
Yeah?
No, sir.
No? Fine. Now we will be going to further problems which we have. We have done, I think, the first problem. Wait. Yeah, we have done the first problem. Now let's take the next problem. Just a moment. Okay. Now ABCD is a rhombus. Let's solve question number 2. Over here, what they have given? ABCD is a rhombus. Okay, let's draw a rhombus. Okay, ABCD is a rhombus. Okay, P, Q, R, S are the midpoints of the side AB, BC, and CD. Okay, if this is P, this is Q, this is R, and this is S. P, Q, R, S are the midpoints of the sides AB, BC, CD, and DA respectively. Show that quadrilateral PQRS is a rectangle. You have to show that this quadrilateral is a rectangle. Means PQRS, if we join, this will be a. Now, what you have, they have given that we'll have to draw all this quadrilateral, means we'll draw all this. This is PS and this is your SR. Okay. And now what you have to prove in this, that is quadrilateral PQRS is a rectangle we have to prove. Fine. This is what you have to prove. Now to prove this, what we will do? Wait. We'll draw, if I draw these two lines. Okay, if I draw these two lines, what I know in this, in triangle ABD, in triangle, in this triangle ABD, I know that S and P are the midpoints, yeah, are the midpoints points of AD and AB. Therefore, can I say SP is parallel to AB? Yeah,
Sir,
SP,
BD.
oh sorry, BD, not AB. It will be SP is parallel to BD. Can I say this? Yeah,
Yes.
yeah, okay. Also, I can say if SP is parallel to BD, so by midpoint theorem, SP will be half of BD. Yeah, so SP will be half of BD. So this is done. Let's keep it. Now also, in triangle, let's keep this as 1, this as 2. Okay, in triangle BCD. Okay, in triangle BCD. So in triangle BCD, can I say over here R and Q are the midpoints? R and Q are the midpoints of DC and BC. Therefore, RQ will be parallel to BD. Yes or no? You can say this as 3 and RQ will be equal to half of BD. Let's say this as 4. So if I seek 1 and 3, from 1 and 3, SP is parallel to DD and RQ is parallel to BD. So can I say from 1 and 3, from 1 and 3, I will say that SP is parallel to RQ. SP is parallel to RQ. Yeah, SP is parallel to RQ. Also, SP will be equal to RQ from, see, SP is equal to half of BD and over here RQ is equal to half of BD. So from 2 and 4, from 2 and 4, what I know, SP is equal to RQ. Why? Because SP is also equals to half BD and over here RQ is also equals to half BD. So I can say SP is equals to RQ. Therefore, what I can say about the quadrilateral, what I can say about this quadrilateral then, if
Parallelogram.
yeah, therefore quadrilateral PQRS is a parallelogram. But what we have to prove that quadrilateral PQRS is a rectangle, right? We need to prove that. Now we know that this ABCD is a rhombus. Diagonals of a rhombus are perpendicular to each other. We know it.
Yes.
Yeah. What do we know? Since diagonals of rhombus are perpendicular to each other, therefore I can say angle, if I say this as PQRS, angle PQRS, if I say this is X, Y, Z and then W. Okay, then angle X, this is O. XOW is equals to 90 degree. Therefore, angle XOW equals 90 degree. Right? Over here, this line is parallel to this line. This line will also be parallel to this line similarly. Yeah. So the quadrilateral XOWQ will be what? Will be a parallelogram. Since, what we can say? Since XOX is parallel to WQ. Also, XQ is parallel to OW, parallel to OW. How? Similarly, as we have proved that OX is parallel to WQ, because this and this are also midpoint, this and this are also midpoint, so this will be parallel to this and this will be parallel to this, and therefore this will be parallel to this. Fine. So therefore, what I can say, that is this quadrilateral, what I can say, therefore quadrilateral OXQW is a parallelogram. Right? Therefore, angle XOW plus XQW will be equal to how much? 180 degree. Yeah? Sorry, not that.
So how?
No, no, not that. XOW plus OXW will be equal to 180 degree. Co-interior angles of a parallelogram.
Sir, OXQ.
Sorry, OXQ, not OXW. It will be OXQ. Will be equal to 180 degree. Why? Co-interior angles,
Linear.
not linear pair. Co-interior angles. Yeah. But we know that XOW is 90 degree. So 90 degree plus angle OXQ equals 180 degree. Therefore, angle OXQ is equals to 90 degree. So if, sorry, OXQ is 90 degree. Yeah. Similarly, similarly, angle XQW will also be 90 degree because this is also parallelogram. Similarly, angle XQW is also equal to 90 degree. Now we know that this is a parallelogram. If any one angle of a parallelogram is 90 degree, then the parallelogram is,
Triangle.
yeah. Since if any one angle, what we can write, since if any one angle of a parallelogram is 90 degree, then it's a rectangle, therefore quadrilateral PQRS is a rectangle. And over here you can say hence proved. Is that clear? The next question is also the same kind of. ABCD is a rectangle, PQRS are the midpoints of the sides. Show that the quadrilateral PQRS is a rhombus. You have to do it similarly as we have done the first question. Okay, we'll not do this. The next is the fourth question.
The third one, can you do?
You want me to do? Fine.
Yeah.
Okay, ABCD is a rectangle. Fine. See over here, ABCD is a rectangle over here. And then we can write over here like this: A, B, C, and D is a rectangle. And PQRS are the midpoints of the sides. Okay. AB, BC, P, Q, R, S. And if I join all of them, okay. Show that the quadrilateral PQRS is a rhombus. You have to prove that this is a rhombus. Okay. This sides are means what is given in this. Wait, just a moment. Now what you have in quadrilateral ABCD, what all things you have? Okay, well, let's draw the diagonals. You need to prove that it is a rhombus. Okay, so over here in quadrilateral ABCD, PQRS all are midpoints. Since P comma Q comma R comma S and S are the midpoints, are the midpoints, therefore by midpoint theorem, by midpoint theorem, what I can say, PS is parallel to BD is parallel to QR. Also PQ is parallel to AC is parallel to SR. Therefore, what I can say, therefore quadrilateral PQRS is a parallelogram. Yes or no? If the opposite pairs of a quadrilateral are equal, sorry, are parallel, then the quadrilateral is a parallelogram. Yeah, we got it that it's a parallelogram. Now we only need to prove that it is a rhombus. That means to prove that it is a rhombus, we need to prove that any one of the adjacent sides are equal. Now how to prove that? We know that in also PS is equals to QR is equals to half of BD by midpoint theorem only. This is also and SR is equals to PQ is equals to half of AC, right? But BD is equals to AC. Why? Diagonals of a rectangle are equal. Since diagonals of rectangle are
So
equal,
can you take the figure down?
yeah, yeah, what you are saying?
So I was saying, can you take the figure down?
Yeah, why not? See over here. See, PS is equals to QR is equals to half of BD, and this SR is equals to PQ is equals to half of AC. But what do we know? That AC and BD are equal because they are the diagonals of them. So if this is 1, this is 2, and this is 3, then from 1, 2, and 3, what do I get? From 1, 2, and 3, what I get? All these sides are equal. PS is equals to QR is equals to SR is equals to PQ. PS is equals to QR is equals to SR is equals to RQ. So all the sides are equal. Therefore, quadrilateral PQRS is a rhombus. Got it? Is that clear to everyone? Now see to the question what they have given. In a parallelogram ABCD, E and F are the midpoints of the sides AB and CD respectively. Show that the line segment AF and EC trisects the diagonal BD.
Sir,
Yeah.
sir, I think you skipped the question.
Sir, you missed the fourth question.
Oh wait. The fourth question is missed. Wait. Okay. Now we hear ABCD is a trapezium in which AB is parallel to DC and BD is a diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. Show that F is a midpoint of BC. This is very easy. See, in this triangle, if a line is drawn through the midpoint of one side which is parallel to the third side, then this line will bisect this. Yes or no? If I write BFG, that is BG will be equal to DG. Yes or no? And again, this line, this DC is already parallel to AB. Yeah. So if DC is AB is parallel to DC and EG is parallel to this, then EGF is also parallel to BC. Again, this is the midpoint. This is drawn parallel to the third side. So therefore, this line will bisect these two. So this side will be equal to this side, and therefore BF will be equal to FC. You'll be,
Sir,
yeah.
sir, but how point E will bisect DB into G?
Please ask again what you are saying. How?
Sir, how will line EF bisect DB
Okay. See.
equally?
Okay. These two sides are equal. They have given.
Yes, sir.
Yeah. And if a line is drawn parallel, see that there is a statement over here. Which one? It is this statement. See, what is the statement? A line drawn through the midpoint of one side of the triangle parallel to another side bisects the third side. Okay? We know this as a statement.
Yes, sir.
Therefore, if a line is drawn parallel to the third side, it will bisect the third side if it is drawn from the midpoint of one side. That means this
Yes,
will
sir,
be equal to
understood.
this. Got it? That is DG will be equal to BG. Got it? Yes or no?
Yes, sir.
Yeah. And similarly, AB will be parallel to DC. Why? Because it's a trapezium. And EF is drawn parallel to AB. Therefore, EF is also parallel to DC. So GF is also parallel to DC. And again, it is a midpoint and drawn parallel to DC. Therefore, again, it will bisect the third side. That is, BF will be equal to FC. Understood? How many of you have understood this? Please raise your hands or type yes in the chat box. How many of you have understood this? Okay, everyone. Okay, fine. You can lower down your hands, everyone.
Sir,
Yeah,
sir, after getting BG equal to DG,
BG is
uh,
equals
it
to
is
DG. Yeah, yeah,
after that AB is parallel to DC, that is given,
yeah.
and uh, what else is parallel
Okay,
to
okay, fine.
AB?
See, AB is parallel to DC. Why? Because it's a trapezium. And this EG is drawn parallel to AB. So if EG is drawn parallel to AB, EG will be parallel to DC also.
Yeah.
And then the extended line will also be parallel, no? This line will also be parallel to DC.
Okay.
Got it now?
Yes.
Yeah?
Sir, so we flip the figure upside down, it will become much easier.
Flip the figure upside down. But how you cannot write it like that.
Yeah,
Yeah? Okay. Clear everyone? You want me to write or you have understood this?
understood.
Understood, no? Okay, fine. Now the next. Okay, this one. What is given over here? In a parallelogram ABCD, E and F are the midpoints of the sides AB and CD respectively. Okay, these 2 points are the midpoint. Okay. Also, it is given ABCD is a parallelogram, right? So AB is equals to DC, and if this is the midpoint and this is the midpoint, so this all distances will be equal. AE will be equal to EB will be equal to DF will be equal to FC. Yeah. E and F are the midpoints of side AB and CD respectively. Show that the line joining segment joining AF and EC trisects the diagonal BD. Okay, so that means this is equal to this. That's what we need to prove. Trisects means what? Trisection will be done when two points are dividing a single line in a three equal parts. Bisection means dividing in two equal parts. Trisection means dividing into three equal parts. Can you try it? Can you try it? Think on it. I'll be starting it after 2 minutes, but you please try doing it on your own. Yeah. What you have to do in this, that is in a parallelogram ABCD, they have given E and F are the midpoints. So this all sides will be equal. Yeah, we know that. Let's take the diagram separately to solve it. Okay. And midpoints of side AB and CD respectively show that the line segments AF and EEC trisects the diagonal BD. Right. Now what is given over here? Let's write the given to prove and all. Okay. What is given? Quadrilateral ABCD is a parallelogram. This is what we know. Also, the next thing which is given is, as per since A and F are the midpoints, therefore AE will be equal to BE will be equal to DF will be equal to FC. Right? This will also come in the given part. And is there anything else given? Yeah. Now what you have to prove? What do you have to prove in this? Show that the line segment AF and EC trisects the diagonal BD. That means the to prove is DP is equals to PQ is equals to QB. Understood? Since it's trisects means what? It divides into three equal parts. Did you understood up to over here? Any doubt till over here? No?
Yes, sir, understood.
Understood. Okay, fine. Now what do you have to prove in? Let's write the proof. Now, if you want to write the proof, yeah, we know that in quadrilateral AECF, in quadrilateral AECF, what all things we know in quadrilateral AECF? AE is parallel to CF. This is given. This also comes under given only, no? Because it's a ABCD is a quadrilateral, that's why. Yeah. You can also write the reason over there that also, that is ABCD is a quadrilateral. Sorry, ABCD is a parallelogram, that's why. Also, AE is equal to CF. That also comes under given. Yeah, from the given part. AE is equals to FC over here. Got it? Therefore, can I say quadrilateral AECF is a parallelogram?
Yes.
Yeah, I can say that this will be a parallelogram. Now, once I know that it's a parallelogram, therefore, AF will be parallel to EF, EC. Yes or no? AF will be parallel
Yes.
to FC. Okay. Let's write this as 1. Now, in triangle DQC, FP is parallel to QC from 1. Yes or no? Are you getting it? FP is parallel to
Yes.
QC from 1 we have it. Also, F is the midpoint of DC. That's given. Therefore, by midpoint theorem, what we can say? Therefore, by midpoint theorem, What we can say, anyone? Yeah?
FP equal to half of GC.
Yeah, that is fine. But we can also say that dp is equals to pq. Yes or no? A line drawn parallel from a line drawn from the midpoint of one side of the triangle parallel to the other side bisects the third side. Yes or no? This line is drawn parallel to this, and this starts from the midpoint, so this will also be the midpoint. Yes or no? So by midpoint theorem, can I say dp equals pq? Yeah.
Yes.
Let's say this has 2. Now in triangle a abp, yeah, eq is parallel to ap from 1. Yeah, from 1 only, no, the 1. AE is parallel to EC, that's why. AP will be parallel to EQ, yes or no? Again,
Yes.
E is the midpoint of AB. Therefore, by midpoint theorem, what I can say? Again, by midpoint theorem, by midpoint,
Q is midpoint of PB.
yes.
Sir,
Therefore,
PQ equals QB.
yes. Therefore, by midpoint theorem, I can say PQ equals QB. Let's say this has 3. So from 2 and 3, from 2 and 3, what I get? From 2 and
All the three sides are equal.
yes, therefore dp is equals to pq is equals to qb. Therefore, hence proved. Is that clear? Yeah. How the three
Yes.
Yes.
means this side is trisecting the single line. The next question. Now what do you have? Show that the line segment joining the midpoint of opposite sides of a quadrilateral bisect each other. Okay, let's show that the line segment joining the midpoints of opposite sides of a quadrilateral bisect each other. Let's draw any quadrilateral. Okay, now what they are saying? Show that the line segment joining the midpoints of the opposite sides of a quadrilateral bisect each other. Means if I take this as the midpoint, this as the midpoint, this as the midpoint, and this as the midpoint. What they are saying, if I join the midpoints of opposite sides, that means midpoints of these opposite sides. Okay, midpoints of the opposite sides of a quadrilateral bisect each other. That means bisect each other means this side is equal to this side and this side is equal to this side. How we can prove this? Anyone over here? Can anyone tell me how we can prove this? If this is ABCD,
Sir, we can try to make a diagonal and make two triangles.
yeah, we can do that. So what we will do, see this is not given. Huh? So first we will write what is given. Wait, we'll write this as A, B, C, D. First we will write what is given. What is given in this? P, Q, R, S. Quadrilateral ABCD is a quadrilateral, you can say. It's not a parallelogram, nothing. It's nothing given.
Sir,
It's a,
you wrote ACDC.
yeah, A, B, C, D. Oh, wait. ABCD is a quadrilateral. Fine. After that, what is given? P, Q, R, and S are the midpoints. Midpoints of AB, BC. Wait, A, B, I should write C over here. C should be over here, D should be. It should always be in a clockwise or anti-clockwise. Okay, PQRS. Okay. AB, BC, CD and AD respectively. Okay, these are the midpoints. That's what is given. Now what do you have to prove? To prove is if this is O, PO is equals to OR, the first, and the second you have to prove SO is equals to QO. Fine, this is what you have to prove. Now to prove this, let's take this diagram to solve. Okay, now to solve this, what are things you have? Let's join all the points. If I join all of them, yeah, if I join all of them, also if I draw the diagonal, but drawing the diagonal is required, yeah. Okay, if I draw the diagonals, and we need to prove that PO is equals to OR and SO is equals to OQ. Okay, now proof. Let's write the proof. Okay, in triangle ABD, in triangle ABD, P and S are the midpoints. So what I can say, therefore, AP is parallel, sorry, SP is parallel to BD. Yeah, SP is parallel to BD, and SP will be equal to half of BD, right? Also, in triangle DBCD, yeah, R and Q are the midpoints. What we can say, in triangle BCD, R and Q are the midpoints. Are the midpoints. Therefore, RQ will be parallel to BD and RQ will be equal to half of BD, right? RQ will be parallel to BD as well as RQ will be half of BD, right? So if this is your 1, this is your 2, so from 1 and 2 what we can say? From 1 and 2,
PQRS is parallelogram.
yes, therefore PQRS, quadrilateral PQRS is a parallelogram. Yeah. Now also, now diagonals of a parallelogram, what happens with the diagonals of a parallelogram? Since, yeah, now what did we get? That is quadrilateral PQRS is a parallelogram. Now, since we know that diagonals of a parallelogram always bisect each other. They bisect each other, no? Diagonals of a parallelogram always bisect each other. So therefore, what we can say? Therefore, what we can say? Therefore, OP is equals to OR and OQ is equals to OS, and hence proved over here. Clear, everyone?
Sir, can you just say in short way?
In short way, if I want you to give you a revision, fine. See
Yes.
what was given over here, that this is a quadrilateral and they have given that P, Q, R, S are the midpoints of this sides. Okay, it's an irregular quadrilateral. We don't know, means it's a parallelogram, rectangle, nothing is given. Okay, these are the midpoints, but that's what they have given. And they have asked you to prove that this side is equal to this side and this side is equal to this side. That is, these are bisecting each other. That's what they have asked. So what we have done, we have joined all the points P, Q, R, S. We have also joined the diagonals. Okay, if we join the diagonals, we know that SP is parallel to BD. Why? Why SP will be parallel to BD?
Sir, midpoint.
Yes, by
Sorry,
midpoint theorem.
midpoint
Yeah,
theorem.
yeah, midpoint theorem only. SP is parallel to BC. Also, SP is equals to half of BD by midpoint theorem. Also, if I take this triangle, I know that RQ is parallel to BD and RQ is half of BD. So with this
Yes.
1 and 2, I can say that SP is parallel to RQ and SP is equal to RQ. Got it? And if
Yes, sir.
for any quadrilateral, if the opposite pairs are equal and parallel, therefore the quadrilateral will be a parallelogram. So what I got, that is this quadrilateral is a parallelogram. Now once this quadrilateral is a parallelogram, I know that diagonals of a parallelogram bisect each other. Right? Diagonals of a parallelogram bisect each other. That's why. Hence proved. Understood?
Yes, sir.
Yeah?
Thank you.
Okay. Now the next. Okay. Over here, what they have given, ABC is a triangle right angled at C. Okay, let's draw the triangle. Right angled at C. Okay, it is right angled at C. After that, this is an ABC, we can say A, B, and C. A line through the midpoint M of a hypotenuse AB. Oh wait, this is A.
Sir, it is B.
Yeah, yeah, this will be AB. Now, a line through the midpoint M of a hypotenuse AB and parallel to BC intersects AC at D. Okay, a line through midpoint AB parallel to BC, they are saying. So it is like this. Parallel to BC meets AC at D. Okay. Now you have to show that D is a midpoint of AC. That's by midpoint theorem, right? By midpoint theorem, we can say D is a midpoint of AC. Yes or no? That's clear? Yeah, D will
The
be the
direct, right?
yeah, you can say because since M is the midpoint of AB and MD is parallel to BC, therefore by midpoint theorem we can say that D will be the midpoint of AC.
Yeah, okay.
Yeah, you can also write it like this. Since M is the midpoint of AB and MD is drawn parallel is drawn parallel to BC, therefore by midpoint theorem, what I can say, D is a midpoint of AC. That's it. Hence proved. The first one is proved. Okay, proved one. You can also write over here. Proved one. Next, MD is perpendicular to AC. Okay, we need to prove that MD is perpendicular to. Now see, since MD is parallel to BC and AC is this is 90 degrees, so this also has to be a 90 degree only, no? Yeah. What we can say, since MD is parallel to BC and BC is perpendicular to AC, therefore it has to be MD has to be perpendicular to AC. Therefore, MD will be perpendicular to AC. Got it? Is this clear?
Sir, can you explain?
See, if you have two parallel lines, okay, and if I draw a line which is perpendicular to this line, this will be perpendicular to this also, no? We can also say it by corresponding angles. See, if I extend these lines, right, these two lines are parallel, so this angle and this angle will be corresponding angle, no?
Yeah.
That's it. You can also write corresponding angles or you can write this also. Anything is fine. Yeah.
Yes.
After that, CM is equals to MA is equals to half of AB. Fine. For this, if I draw this CM as the line, okay, and I'll take this triangle below. See, we know that M is the midpoint of AB, right? We know that already. Now, in triangle AMD, and triangle CMD. What all things we know? DM is equals to DM. Why? Common.
Common.
AD is equals to DC, since D is the midpoint. Yes or no? We have already proved it that D is the midpoint, so we can write it. Yeah, AD is equals to DC, so the two sides are equal. Also, angle ADM is equals to angle ADM is equals to angle DMC. Sorry, MDC. What is the reason? Each 90.
Yes.
Therefore, triangle AMD is congruent to triangle CMD. By which test?
SAS.
Angle side. Yeah, SAS. By SAS test of congruency. Yeah. So if the two triangles are congruent, can I say AM is equals to CM?
Yeah.
By CPCT? Yeah. AM is equals to CM, I can say by CPCT. And if AM is equals to CM, we already know that AM is equals to BM. AM is equals to BM.
Yes.
This was given. Therefore, AM is equals to BM is equals to CM. Okay. This is what is proved. But what they have asked is also equals to half of AB. That's fine. No? If AM is equals to MB, it will be equal to half of AB. Will be equal to half of AB. Clear everything?
Yes.
Yeah?
Yes.
Okay. So guys, over here we are done with this chapter, that is quadrilaterals. Okay. Now today you all again have a class at 7:40. Over there we'll be starting with the chapter circles. Okay. Chalo then. Bye bye everyone. Have a good day.
Nice.